Hello and welcome again to this YouTube channel. Okay, now that we already know how to solve the limit of a function based from three different methods. Okay, now let's see whatever happen if we have a quite a complicated function that we have in place. Okay, let's see. This is your function f(x). You can see this function, it has a lot of different values. Okay, the first segment on your left hand side from -6 until 1. Okay, x from your -6 until 1, you have a continuous function, more or less. And then from your 1 until 8, you have similarly quite like a cubic function. Okay, normally we call this all a composite function. Okay, it's a composed of a few different function put all together. So let's say I want to find the first limit. Okay, let's say I want to know what is my limit for my fx when my x goes to -4. Okay, now based from this equation, okay, you can see over here, okay, how to solve this. First of all, you need to find, as usual, your limit when your x goes to -4 from your right hand side. So in this case, your right hand side, meaning that from here to -4, and then your function now would be like this, right? So you can see over here, your function is, sorry, it's over here. Okay, your function now becomes 2. And then if you check your limit fx, okay, when your x goes to -4 from your left hand side, now in this case, your left hand side would be over here, and then your function value now comes from the left hand side until number 2 over here. Okay. Okay, you look at this one. You have the first value 2 and the second value 2. Okay, that's fine, right? So now your value is 2. Okay, that one is clear. Now, the interesting part of this is, okay, let's say if we need to find what is the value for my f2. Is this value 2, or is this value does not exist? Okay, or which value is it? Okay, so this is the most significant difference between when you have a limit or when you have a value to be plugged in inside your function. Okay, if you talk about limit, because limit means that your x is approaching to certain values. When you talk about limit, meaning that you have 2 is your value for your limit fx. All right, but when we talk about this, the value for your function when your x equal to 2, now in this case, your number 2 is not your value for your f anymore. Okay, in this case, your function when your x equal to 2 does not exist. All right, does not exist. Why that is so? Okay, we refer back to our function over here. You can see over here, okay, I put a circle there. Okay, there's a slightly no value inside this. This is a circle that is void. Okay, a void circle. That's why your f2 does not exist. Okay, that one is clear, right? Okay, this the difference between your fx and the difference between your limit of fx. Okay, so that one is clear. Now let's see the situation where your limit does not exist. Okay, this kind of situation, you can focus your attention to your x equal to 1. Okay, you can see over here, if let's say I need to find my limit, okay, for my fx when my x equal to 1, the same thing happen. First, I need to find my limit from my right hand side, and also I need to find my limit for my fx when x goes to 1 from my left hand side. Okay, so we proceed with 1 from my right hand side first. Okay, and you can see over here, 1 meaning that my x is goes to here, and then my value, okay, you always have to remember the function happen when your y is defined. Okay, so basically this is the rest of your function. Okay, this is the rest of your function, and it will approach to number -2. Okay, that one is clear. And then we move forward to one from the left hand side. Okay, remember you need to move your cursor from your x perspective, and then later on you corresponds the x perspective into your y value, which is over here, and then you proceed to this side. Okay, so meaning that your y now is equal to 4. Okay, now you can see clearly over here, when you put that into equation, your limit for your fx when x goes to 1 from your right is not equal to your x goes to 1 from your left. Okay, so once this does not mm, equal, that means that this one is you can write like this. Okay, your fx does not exist. The limit of your fx does not exist. And then surprisingly, whatever happened if let's say you need to find your f1? Okay, this what makes it interesting. Okay, look at this one carefully compared to the previous example. F1, you can see over here when your x equal to 1, your y is defined in this section, right? Because the dotted line, the dotted circle over here representing the value for your fx. So meaning that your f1 equal to 4 in this case. Okay, so this one in this particular problem, your f1 exists, whereas your limit for your f1 fx when x goes to x does not exist. Okay, so it's a little bit tricky at first, but I think once you keep on doing the similar form of illustration, okay, in a graph form, then you will see there are not that tricky anymore actually. Okay, so all the best. I see you guys in the next lesson.